So your test on relativity is going to be next class. I'm probably going to put 2 or 3 relative speed questions. Heck, I'll bet you one will be something like a rabbit getting chased by a wolf. There'll definitely be a train question like this, either coming towards each other or going in the same direction. And then probably the police car bad guy question. Then the rest of the test will be special relativity, traveling near the speed of light. Okay? For the last time, who's my favorite student? Good old Anne. I like number 1, I like number 1, I like number 1. Number 1 is, well, it's already on a quiz, so I guess it's pretty obvious. How long, what's this question asking me to find? Time. Are we traveling near the speed of light? No, so this isn't going to be relativity. But Annika, are there 2 objects traveling at different speeds? This is a job for relative speed. So T equals question mark. D equals, for them to pass each other, I'm going to argue that the back of one train has to get all the way past the back of the other train. So I'm going to argue the distance is 120 and 450 and 80. 120 plus 80 is 200, so I think the distance is 650 meters. And then I'm not going to use V, I'm going to use what I call VREL, the relative speed. They're heading towards each other. What's worse, head-on collisions or getting rear-ended? Head-on, I'm going to add the speeds together because that's why it's worse. That's how I always remember what I do with the 2 numbers. So VREL is going to be 16, yes? If they were going in the same direction, 4. And then we use D equals VT. What happened to O to the half AT squared? What's A? 0. And then in your original equation, it's D equals VIT, but if you're not accelerating, VI and VF and V average are all the same because you're going at a constant speed. And in fact, really what I'm arguing is that's the relative speed that I'm going to use right there. How would I get the T by itself? So it's going to be 650 divided by 16. You get 40.6, 40.6 seconds. Is that right? Yep. So I would give you 3 out of 3 for that. Otherwise, I would definitely give you 1 mark if I saw D equals VREL T. I would give you, believe it or not, a half mark if you found VREL correctly. I would give you probably a half mark for that, a half mark for the numbers, and a half mark for the answer. I think that adds to 3. Oh, good. Here's 2 in the same direction. It's going to be an almost identical question. Apparently, they're asking me to find T. By the way, could I tell you the time and could you find the distance? I think so. Could I tell you the distance and the time and ask you to find their relative speed? I think so. I don't know if I do on the test, but for what it's worth, it's one of the reasons I've taught you this formula manipulation shtick is once you know how to do it one way, you can solve for whatever. I think the distance is going to be that. The back of the back train has to get past the front of the front train. So it's going to be 150 plus 450 plus 100. 150 plus 450 is the distance 700? And VREL is 8. Yes? So D equals VREL T. T equals D over V. It's going to be 700 divided by 8. $87.5. You good, Deegan? Okay. Same as before. I'd probably give you 1 mark for that, half mark for finding VREL, half mark for getting the t by itself, half mark for the numbers, and a half mark for the answer. Ooh, now we're in special relativity. So if you want a good idea of what your test is going to look like, look at the study guide. I wrote the test first this time, then I pasted the test into the study guide, added more questions, and changed the numbers. So this is going to be a pretty routine, no surprises test. They want me to find, this question asking me to find L or L0. How do I know? 620 is at stationary, at speed 0, at rest. So L0 is 620. V is 0.96 c. They want me to find L. I think it's L equals L0 times the gamma thingy, I think. So it's going to be 620 times the square root of 1 minus 0.96 c over c all squared. Do you see? Do you see? Do you see? 620 square root of 1 minus 0.96 squared. So I'm taking more shortcuts and doing it all in one step more often. Figure out how your calculator works. I hope you have by now. 173.6 meters. A 45-meter-long asteroid is shot past a stationary space station at 98% of the speed of light. What length do the people on board the space station measure the asteroid to be? This is worded awkwardly, but I think what they're telling me is find the relativistic length, because the space station people are at rest relative to the universe, and so they're seeing the rock go past. They're going to see it, the asteroid go past. They're going to see it shorter. So I think L0 is the 45 and V is 0.98 c. I think we're going to end up with L equaling 45 times the square root of 1 minus 0.98 c over c all squared. Hey, I wonder if I can just backspace and edit a little bit here. I think if I go 0.45 and 98. Is it 8.95 meters? Pardon me? At that speed, yes. Okay, now they want me to find the mass of the rock at this speed. So I think here they're asking me to find the relativistic mass. I think M0 is 65. V is 0.99 c. I have a bit of a built-in error check. I've memorized that for the moving object, time is smaller. For the moving object, length is shorter. And for the moving object, mass is bigger. So I kind of look at my answers and compare them, and then I can kind of figure out if I've gotten L and L0 mixed up. Here it's going to be M equals M0 divided by that, if I recall. Yell at me if I'm doing this wrong, because I'm kind of going from memory. 1 minus 0.99 c over c all squared. 65 divided by the square root thingy. You get 461 kilograms? Yep. Yep. But not 460.7. Take a half mark off. Okay. And I think I told you at the Large Hadron Collider, when we're smashing protons into each other, we have to take into account, when we look at all of our results, that the mass of the proton has increased at that speed. We've measured this. The Starship Enterprise passes you at a speed of 0.98 c. You measure its length to be 144 meters. How long is the Enterprise at rest? Oh, okay. So I think this is asking me to find L0. I think L, this is what I measured when it went zipping past me. 0.98 c. So L0, I think, is L divided by the gamma thingy. I think it's going to be 144 divided by the square root of 1 minus 0.98 c over c all squared. 144 divided by the square root of 1 minus 0.98 squared. 724, 723.6, which for those of you who are Star Trek fans will know that that is the length of the Enterprise. Which one, Mr. Dewick? Enterprise D from Star Trek The Next Generation. I'm a Star Trek nerd, I know. NC 1701. Number 7. A friend borrows your red Ferrari spaceship model X blah blah blah. Capable of traveling at 0.95 C. Gotcha. How long would you say the Ferrari is as it sped by you at maximum speed? So I think this is asking me to find L. The question is, am I going to use the 5.6 or the 18 meters? I think if I'm kind of trying to visualize what's going on, I think there's the Ferrari, where this is 5.6 and 18 long. And I think as it scoots by me, I'll see it shrunk down in the direction of its travel. Its height would stay the same. So I think L0 is 18. If you used L0 5.6, I'll give you 1.5 out of 2. L is going to be L0 times that. It's going to be 18 times the square root of 1 minus 0.95 C over C all squared. 18 times the square root of 1 minus 0.95 squared. Oh, wrong button. Do you get 5.62? So it would almost look square because its height was 5.6. This long, you can kind of imagine the Ferrari spaceship. It would look like this kind of square, stubby spaceship now to your eye. Did you use 5.6? That's okay. So you would go 5.6. I would give you 1.5 marks if you said 1.75 meters, which is probably what you got. Your friend has been gone for 5 hours of your time. Is my friend on board the spaceship or on board the spaceship? So how much time does he say has elapsed? I think my friend is we are wanting to calculate time on board. Time back home was 5 hours. The speed was still 0.95 C. So T0 is going to be T times the gamma function, I think, yes? It's 5 times the square root of 1 minus 0.95 C over C all squared. Oh, this is nice. I can probably just backspace and edit and change the 5.6 that I did for Max to a 5.0. You get 1.56. And by the way, common mistake, this is in hours. I always have some student that says, oh, 1 hour, 56 minutes. Is 1.56 hours 1 hour, 56 minutes? What's 0.5? What's half of an hour in minutes? Yeah, this is a little longer than 1 hour, 30 minutes. Probably about 1 hour, 34, 1 hour, 35. So I'm just going to write 1.56 hours. If you actually felt like you had to convert this to minutes, what's 1 hour in minutes? How would you turn a 1 into a 60? 93.7 minutes. So 1 hour, 33 and a bit. 1 hour, 33 and a bit minutes. Whatever. If you notice, whenever I say find V, it says this is tough. And that's because I gave you the V equations on your green sheet. I used to not do that. I used to make the kids pull the V out of inside that square root. And it was okay, but it was really overkill. I love formula manipulation, I really do, but Camille, that was just overkill. So I finally relented, but I keep forgetting to remove the "this is tough" little phrase, because this is definitely asking you to find a speed. I guess m0 is 2 and m is 4. Now, how did I know that? Because I know mass gets bigger as you speed up. So I just used that. V is going to be c square root of 1 minus, is it m0 over m all squared? I think I'm going from memory here. I will take two answers here, because here I did not specifically say, give me the answer as a percentage of the speed of light, or give me the answer in meters per second. So I'll take both. On the test, there will be one question where I say, give me the answer as the percentage of the speed of light, and there will be one answer when I say, give me the answer in meters per second. So I'll show you how we do both. If I want to get the answer as a percentage, I just leave the c as a c. I would just go square root of 1 minus 0.5. I went 2 divided by 4 in my head. It's 0.5. So this is 86.6% of the speed of light. So if you said v equals 0.866 c, or 86.6% of c, I would give you full credit. How would I convert that to meters per second? Well, I would actually multiply by c, which is 3 times 10 to the 8th. 2.598. A good place to round off is probably after the 8, where there's a 0. So 2.598 times 10 to the 8th meters per second. I would take either of those. Okay. Basically, and a lot of people who specialize in special relativity, or you'll often see this in made-up questions, if I want the mass to double, the length to cut in half, or if I want the spaceship to age half as fast, 86.6% of the speed of light will do the trick. I always remember it's 1% more than an A. Yeah. Yep. But I'd also say, hey, let's be a little more accurate. I like number 9. You know what? I love number 9. Number 9, will you marry me? Yeah. Okay. There's going to be one like this. I like this because in one question, we really get a feel for how wonderfully strange space travel would be. So a certain star is 40 light years away. Remember, light years is a distance. How long would it take a spaceship traveling at 99.5% of the speed of light to reach the star as measured on the Earth? So right now, since we're measuring by the stationary observers, we're not going to use relativity. We're just going to use what happened to Owen to the plus a half AT squared. What's A? Okay, come on, got your Q. Okay. And again, this is why Einstein took 10 years to work acceleration in, because that's much trickier. So I think I'm going to go like this. T equals d over v. The distance is 40 light years. The speed is 0.995 c. Wonderfully, the c's cancel, and I get years. By the way, if I was traveling at the speed of light, how long would it take? Exactly 40 years. We're nearly the speed of light. I'm going to guess that you're going to get an answer just slightly bigger than 40. It's not going to take you 60 years. $40.2. 0.2 of a year would be 1/5 of a year. So a little over 2 months. 2 months, or sorry, a little over, yeah. As measured by observers on the spaceship. Okay, they are the ones that are moving relative to the Earth. So now it's asking us to find time on board. That's going to be T divided by gamma or times gamma? Times gamma? So what T? The time that passes on the Earth. I wrote 40.2, but you know I'm going to use my answer button. Times square root of 1 minus 0.995 c. Do you see c's cancel? So I can just go with that. Ooh, 40.2 years back home, 4.015. If you said 4.0, I'm fine with that. I'm going to write 4.015 just because I suspect I might want to use this answer for another question later on. So this is almost a 10-to-1 time dilation. So yeah, 99.5% of the speed of light will give you pretty close to a 10-to-1 time dilation. What's the distance according to the observers on the spaceship? There's two ways that you can do this. I'll give you full credit for either. You could go, well, distance equals that. It's going to be 0.995 c times 4.015 years. Can you see I get light years in my units, which probably tells me I'm doing this right? This is really why at the beginning of the year I did that dimensional analysis unit conversion shtick, is you can look at your units and say, I got the right units, this must be what I do with these numbers. So if I take this answer button and I go times 0.995, even though we have measured the distance to be 40 light years, they will only travel 3.99 light years. Pardon me? Yep, 3.995. I'll even add the extra sig fig to make you happy. Or you could have done it this way. We are finding the relativistic length. So the original length at rest was 40. The speed we're traveling at is 0.995 c. So you could also have gone 40 times the square root of 1 minus 0.995 squared. And what I love is you get exactly the same answer. This is a confirmation that the length equation works. I never derived the length equation with you folks. Can you give yourself a lovely score at the top of this quiz out of 26, please?